Hello there, and welcome back to another day where you have some free time. And in this day's video of unstd-c, well, we will be debugging what has gone wrong in the last video. But based on this result of GDB, the problem is in the next chunk. So in malloc internal, where I did not really follow what I've said over here, if c is equal to null, then we return d plus 1 as a struct of heap chunk type. And now that I'm seeing this, maybe I should also add a status in here that will just check if d is null and if c is equal to null, then we return the same thing. Wait, no, there shouldn't really be a previous chunk if the heap chunk is null. So if c is null or its previous size is equal to null, wait, no, not null, 0, then we return null. And that is pretty much it. So let's try again with a clean build. Then we will rebuild that, run strace. And now we have the unmaps and the likes. Now, well, instead of me sorting the free chunks, we will just traverse the whole block for chunks with the metadata. And we will try to merge as much as possible. So let us declare some functions for that. So was it the third one? Yes, it is. So let's have this return a Boolean value if it's able to merge the chunk after the chunk that we've provided to it. So heap chunk, no, the heap data first, then the heap chunk C. And we have a void function that will merge all three chunks. That will just take the heap data, D. And this is what we'll use in malloc when there is no, what do you call this? Well, if it was able to find a suitable block, but we have not really checked yet if, well, what do you call this? We have not checked yet if it's suitable to be the chunk that we will return, but we will merge it nonetheless. So merge three chunks. So for that function, we'll go back to malloc internal C and actually define that. So merge three chunks, struct heap data D, and also the one that will return a boolean. So merge chunk after. That will take the heap data as well as the chunk. So it will try to take the next chunk. So heap data T, no, heap chunk T next. is equal to next chunk, D and C. And if the next chunk, oops, if the next chunk is equal to null, or the next value's free status is false, then we return null. And then if we're cool with that, then we also find the next one after the next one. So just call that next. So D and C. And if this thing is not null, then we change its value, well, the previous size anyways, to be equal to the size of C plus the size of next plus the header size. So we gain a extra header size when we merge chunks. And we do the same thing with size over here. In fact, maybe I can just copy that over. And that is pretty much it. We just return true. And now that I'm thinking about it, this should not be null but false. Okay, now that we have that there, we define a struct for the heap chunk. Just call that C maybe. Set that to null. And we do a while loop. But while C, when we try to find the next chunk of that, D and C, while that is not equal to null, then we do two conditions. If the merge pre-chunks after on this returns true, then we just continue on. Else, we go to the next chunk, which is, I guess it's a bit counterintuitive if I do that in the condition. So we'll do that here in the else condition instead, and see will be checked if it's null or not. And I guess we can start this out via next chunk, setting this to null. Well, the dogs are getting loud. So, oh, they've calmed down. But anyways, maybe this will work now. So we merge the chunks, and if it's able to merge them, we continue on to merge the multiple free blocks, if they are adjacent to each other. And that is that. So let's go to malloc. Let's see. And let's try building this. Oh, why is that merger? I guess I spelled it wrong. I guess the same thing goes for malloc internal then maybe. No, I just screwed up that at the header. And then forgot the semicolon. That is fine. Now let's run strace on that and see that we're unmapping successfully. And in build.c, no, in hello.c, I do not have that buffer open. We're actually writing 9 bytes on what we've allocated as 8 bytes. So that will result in some heap corruption if, say, suddenly we've decided to allocate C and we allocate around 99 bytes. And we try building this, run strace, and now it suddenly does not free the first chunk that we've mapped. So yes, that is gonna be a problem. And let's run that by a GDB. And I'll do a cut over here and see what I can find. Hmm. Considering that it cannot find a free chunk in our first heap memory, then maybe the problem is how we trim the first one here at A. So let's see. Let's print out D plus 1 and we try to get that as a struct of heap chunk pointer. So yeah, it uh, it did not really do that. So let's go to the trim chunk or in malloc internal C. So trim. Though we do set the freed status of this and reset the size. So maybe the way we find free chunks is the way, or maybe that's wrong. Though, hmm, I'm not sure about this yet. So let's rerun this again and see that the newly allocated one has a size of 4064, same address that we've been checking earlier. And when we trim that, still the same address, but with new data. So, okay. Now when we allocate a new one, well, maybe the problem is in merge free chunks. So, okay. I think I get the problem. It gets the first chunk, then it sees that the next chunk after that is free. So it tries to merge it back again. So that is a problem. So if this chunk is used, then we return false. We do not want to change the chunks that have been allocated already, unless it's for changing the previous size. That is fine. But the current size of that chunk is a no-no. So I've overlooked that. So let's run strace again. Still nothing, but there's now only two M maps. So that is fine. Now let's try seeing what we can find in GDB once more. So another pause. As I've copied the address of C, the one that we've allocated 99 bytes for, let's see what will happen when we allocate B, the one with the big block. So let's go through this step by step and print out that one again. So that is still the same. And print that out. Still the same. Now, what is the status of that now? Still the same. And C over here is 8192. That is fine. But now when we let the stream chunk come to pass, surprisingly, it's still the same. So, I wonder why this block is not being read properly. So, Let us get this written out. Nothing's changed. Nothing's changed here. So when we free A, then we see the current size of D. So 3924. And when we try to add the size of A that to here is 3933. And the size of the headers, I think, is 32 bytes when it aligns it by 4 bytes. So that is 3965. Now what if we add 32 to 99? That's 131. And when we add that back here to 3965, that's 4096. So I wonder why did that not free it? So let's see the status of this now. It's 3965. So we're freeing B. That is good. It unmapped it. Oh, did I actually not free that? Well, that will be embarrassing if I done so. So let's free C when we've done that. So build, then strace. Now we have a proper unmap of this thing. Oh, thank goodness. So I guess we're sort of free from malloc now, eh? And we may be able to do IO in the next video. So thank you for sticking to me this far, and may I see you on the next one.